Hello children, this video is for class 8th chemistry and actually it is the continuation of our topic elements, compound and mixture. In my earlier video, I told you about elements, compound and mixture along with their characteristics. Now in this video, I'll tell you how to differentiate between compound and mixture. For that children, you need 10 grams of iron powder or iron fillings and 10 grams of sulfur. Actually, for preparing mixture, you can take any amount. Means that it's not necessary that you need to take this much amount of iron or sulfur. You can take iron and sulfur in any proportion. So, when a grinded powder of iron and sulfur is taken in watch glass, we call it a mixture. On the other hand, when a mixture of iron and sulfur is taken in fixed amount and heated, a black shiny compound called iron sulfide is formed. That means when we are heating them, they combine chemically and results in the formation of compound. So children, now you have followed how to prepare mixture and compound using the same components. Here we have taken iron and sulfur. But suppose if you want to separate the components, then what you have to do? See, in case of mixture it is very easy. Using physical method, very easily you can separate iron and sulfur. So in case of mixture, if you will bring magnet near the mixture, the iron filling will cling to the magnet and sulfur will remain in the watch glass. So very easily using physical method you can separate the component of mixture. But in case of compound, the components of compound cannot be separated by physical methods. Why? Because the components are chemically combined. So they cannot be separated by physical method. So if you will bring magnet near the compound, then what will happen? The iron of iron sulfide will remain unaffected. Why? Because the properties of components, they get changed once they form a compound. But in case of mixture, the properties of components are retained. That's why in case of mixture, very easily iron fillings, they cling to the magnet. Now children, let me tell you another way of differentiating mixture and compound, or by observing the effect of hydrochloric acid on mixture and compound, you will see what will be the effect. So when hydrochloric acid is added to the mixture, it retains its individual properties and iron of the mixture reacts to form hydrogen gas. How will you say that the gas which is evolved is hydrogen gas? By bringing burning splinter near the mouth of the test tube. If it burns with blue flame and pop sound, that means surely it is hydrogen gas. And you can see the reaction also shown, that when iron and sulfur, it reacts with hydrochloric acid, it forms ferrous chloride and hydrogen gas is liberated. And in test tube you can see the unreacted sulfur. But when hydrochloric acid is added to the given compound, that is iron sulfide, then it will liberate hydrogen sulfide gas. And how will you identify this gas? With its rotten egg smell. So children, if hydrogen gas is liberated, that means hydrochloric acid is treated with mixture of iron and sulfur. And if hydrogen sulfide gas is liberated, that means hydrochloric acid is treated with compound iron sulfide. Now children, after using inorganic acid, that is hydrochloric acid, for differentiating compounds and mixture, let us use one organic solvent, that is carbon disulfide, for differentiating mixture and compound. So when carbon disulfide is added to mixture, what will happen? Sulfur will dissolve in carbon disulfide, leaving behind iron. You can see the picture their undissolved iron has been shown. But when same organic solvent, that is carbon disulfide, is added to the compound iron sulfide, then no visual change is observed. This indicates that the compound is insoluble. That means it remains undissolved in carbon disulfide. So the properties, they remain unchanged in case of properties of constituent remain unchanged in case of mixture. That means the constituent, they retain their properties, whereas in case of compound the properties get changed. Hope you have followed how to differentiate between mixture and compound using magnet, hydrochloric acid and carbon disulfide. Now children, after learning the difference between compound and mixture, let us learn the types of mixture in detail. Already you know that mixture can be classified into homogeneous and heterogeneous mixture. And this classification depends upon the composition of mixture. But mixture may exist as solid, liquid or gaseous state depending upon the physical state of the component. So there are 5 types of mixtures. First one is solid-solid mixture, second solid-liquid mixture, then liquid-gas mixture and liquid-liquid mixture, and fifth is gas-gas mixture. Now I will give you few examples of solid-solid mixture. So look at the picture shown of brass, bronze, solder, means any alloy, and the second picture shows common salt and sand. So these are the two examples of solid-solid mixture, but they differ in their nature. See, first picture means brass, bronze, solder. These are homogeneous in nature, whereas the mixture of common salt and sand is heterogeneous in nature. Now let us move on the examples of solid-liquid mixture. Now look at the picture of sugar in water and sand in water. See, both are example of solid liquid mixture, but sugar in water is homogeneous in nature, whereas sand in water is heterogeneous in nature. You can see the composition of sand in water is non-uniform and sugar mixes well in water. So we get uniform composition. That's the reason sugar in water is homogeneous and sand in water is heterogeneous. Now the third type of mixture is liquid-liquid mixture, and I'll give you two examples of liquid-liquid mixture. One will be homogeneous, the other one will be heterogeneous. So look at the picture of water and alcohol, and second one is carbon tetrachloride and water. See, water and alcohol are miscible liquids, so you will get homogeneous mixture, whereas carbon tetrachloride is an organic solvent. It do not mix with water, so you will get heterogeneous mixture. But both are example of liquid-liquid mixture. Now the fourth type of mixture is liquid-gas mixture, and here are the examples of liquid-gas mixture. Look at the picture of aerated rings. All of you have seen the bottle of aerated rings, means soda water, in which carbon dioxide is dissolved in water. We know carbon dioxide mixes well with water, so what we will get? A homogeneous mixture. But if you will see the arrangement showing sulfur trioxide dissolved in water, then it do not mix like carbon dioxide. So what we will get? A heterogeneous mixture. Alright children. Now the last type of mixture is gas-gas mixture, and I will give you a very common example, that is air. We all know that air is mixture of gases and it is heterogeneous in nature. Can you see the picture? The smoke coming out from factory means the pollutant near the chimney, they are more dense there as compared to the area which is far away from the factory. So the composition is not uniform. That means air is a example of gas-gas mixture and it is heterogeneous in nature. I hope you have followed the type of mixture along with the nature of mixture. Thank you.